morning. Today we are going to discuss the remaining 4 points of pointers. First one will be the pointers. What's the relationship between the pointers and structures? Second one, accessing structure elements through pointers. Third one, pointer given as an element of structure. And the last one, self-referential structures. So first we are moving on to the topic pointers and structures. So in the last class, we have studied how to declare a structure pointer. So the syntax of declaring a structure pointer is structure name followed by an asterisk sign, pointer variable. Structure name followed by an asterisk sign and the pointer variable name. So here I have given two examples. The first example is of declaring a pointer variable outside the structure definition, and the second one is declaring the pointer variable along with the structure definition. So here I have created a structure named employee. 3 data members I have given here: e-code, e-name, salary. And outside the structure definition, I have created a pointer variable EPTR. This is a pointer variable of type of user defined data type employee. Here also I have created in the second example also I have created a structure named employee. 3 variables I have given: e-code, e-name, salary, and I have created a pointer variable EPTR. EPTR is a structure pointer variable, but the difference is that here EPTR is defined outside the structure definition. Here EPTR is defined along with the structure definition. This we have studied in the previous classes. Okay, so this is a graphical representation of this structure. See, here I have assumed this is a base address. This 1000 is the base address. So from 1000, 4 spaces will be reserved for e-code because e-code is of integer type. So integer type take 4 bytes of data. So 4 bytes will be occupied by e-code. Then followed by 1000, 1001, 1002, so 1003. And from 1004, it will be reserved for e-name. E-name is of character type and each character will take 1 byte of memory. So from 1004, 1004, 1005, 1006, 1007, 1008, 1, 2, 3, 4, 5 till 1008. From 1004 to 1008, memory will be reserved by the e-name, and from 1009, the memory will be reserved for float. 4 bytes here also 4 bytes will be required for the salary. So from 1009, 1010, 11, 12, 1012. From 1009 to 1012 will be occupied by salary. Now see, here this is the EPTR pointer variable. We know that a pointer variable always contains a memory address. So here the EPTR contains the base address of the user defined data type employee. Here the base address is 1000, so the EPTR will contain the value 1000. So this is a graphical representation of the above example. Okay. So next we are moving on to the second topic, accessing structure elements through pointers. This means how we can access the structure elements using pointers. This is the point we are going to discuss in this topic. Okay. So to access the structure elements through pointers, in the previous classes we know that to access the structure element through we have already studied that to access a structure element, to access a structure data, we have to use the structure variable dot element name. That is the syntax we studied before. But there is a slight difference in the case of structure pointer. Here we cannot use the structure variable to access the data elements through structure pointer. We have to use the structure pointer name, and we are using a new operator. Here the operator name is arrow mark operator. So structure pointer name, arrow mark element name. That is syntax of accessing elements of a structure through pointers. So here, hope you are clear with the syntax. The syntax is structure pointer followed by an arrow mark. In the previous cases we have studied it is a dot operator. Here we are not using a dot operator. Here we are using a arrow mark because we are using a structure pointer to access the element of the structure, not the structure variable. If I am using structure variable, I have to use the dot operator, but here we are using the structure pointer followed by an arrow mark, then comes the element name. Now I have given an example. Employee contains three data: e code, e name and salary, and I have created a structure pointer EPTR. Now see, to access e code using EPTR, this is structure pointer, I have to give a structure pointer name. Here the structure pointer name is EPTR, so here also I am using EPTR followed by an arrow mark. Here I am using arrow mark, here also I am using arrow mark. And if I want to access the e code, I am giving EPTR arrow mark e code. So this will access the employee code from the structure employee using the structure pointer EPTR. And the next sentence I have given EPTR arrow mark e name. What does it mean? It means that EPTR we can access the employee name from the structure employee using the pointer variable EPTR. Next I have given EPTR salary. What does it mean? We can access the data member salary from the structure employee using the pointer variable EPTR. So to access the data member of a structure using the structure pointer, instead of using the dot operator, I am using the arrow mark operator. Clear? Okay. So now we are going to the third point. In this, we are going to look how we can give a pointer as an element of the structure. So a pointer will be an element of a structure. So we are going to look how this will work, what are the advantages of you giving the pointer as an element. All the things will be discussed in this portion. So I will start this explanation with an example. Here I have created an employee. The previous example I have given here, struct employee. I have given e code, e name, salary. In addition to these data members, I have introduced a new data int star IP. See, here IP is a pointer variable. See the previous data members, these are not the pointer variables, these are ordinary variables. But here I have included a pointer as an element of the structure. Here pointer comes inside the structure, so this pointer becomes the element of the structure. What does it mean? What does this sentence means? We have already studied. This means IP is a pointer variable which can hold the memory address of a integer value stored in the memory. Okay, so this is a pointer, this is a heading, pointer as an element of a structure. So we have introduced this concept, we have included a pointer inside the structure, not outside the structure, inside the structure. So here I have again declared a pointer structure variable EPTR. This is not a structure variable, this is a data member as a pointer, and this is a pointer structure variable. This is a pointer structure variable. Now let us see how this will work. Here I have given some of the examples for understanding it clearly. See, in the first sentence I have given as C in EPTR and arrow mark e code. What does it send? What does this section means? EPTR. EPTR e code means I am going to access e code from the structure using the pointer variable EPTR. Okay, I am going to enter e code through this sentence. That e code will be accepted by the structure employee. Okay. In the next sentence, I am going to give the employee name through the pointer variable EPTR, and in the next sentence also I am going to give the salary through the pointer variable EPTR. So e code, e name and salary I have given through the pointer variable EPTR. Next, see. Next I am going to input the data to a pointer member, not pointer variable, pointer member, structure member. So I am going here I am going to give data as follows: EPTR arrow mark IP. This is the method we are using to access the data member or to enter the data member. Here I am using the new operator. New operator is used to allocate memory dynamically, and I have given as int of 5. We have already studied this expression before. This means the new operator will allocate memory for storing integer data and that memory location will contain the will contain the data 5. So in effect, EPTR of IP will contain the data 5. That means the pointer variable IP points to a memory location, and that points to a memory location which can contain integer data, and the data will be 5. That is the meaning of this sentence, this statement. Okay, and now see, I have given a cout statement here. Cout star EPTR arrow mark IP. We know that star always denotes a value at. So what I have said here, to display the data of the pointer variable IP, of the data member pointer variable IP. So here in the previous sentence statement, we have entered the data as 5. So here the star value will extract the data stored at the location of EPTR IP, and the data 5 will be displayed. And in the next sentence, I have given as int n is equal to EPTR arrow mark star IP plus 1. So here also this representation also represents the data that is stored in the pointer variable IP. So here also it will take, in the right, we know that assignment is always done on the left side, so the right portion will be executed first. Here also EPTR arrow mark star IP will retrieve the data 5. Okay, it retrieve the data 5 and plus 1 is added, that means 6 will be the answer, and that 6 will be assigned to n. So here n will have the value 6. So in short, we can understand that to access the data member, to input or access the data, the pointer variable inside the structure, we can give as star EPTR arrow mark IP or EPTR arrow mark star IP. These two representations can be used to access or to enter the value to the IP, or to access the value from the IP, which is a pointer variable declared inside the structure, which is a pointer variable which is declared inside the structure. Clear? Okay. So now we are going on to the last point, self-referential structures. So this is a very important portion of structures, self-referential structures. What do you mean by self? Self-referential means it is referred to itself. That's the meaning of self-referential. So the structures which are referring to itself are known as self-referential structures. Or in other words, we can say that one of the elements of the structure points to the same structure. Okay, we can say that if a structure, if one of the elements of the structure points to itself, that type of structures is known as self-referential structures. Once again I repeat, if an element of a structure points to itself, what do you mean by points to itself? Here I have pointed to the same structure name, employee. So this pointer will point to the same structure, employee. Okay, so that's the meaning of self-referential. Self, it points to itself. Here EP points to. So this is an example of employee. Here I have created a structure employee. I have given the first data member as eCode, second one as ename, third one as salary. Now the fourth data member I have given as a pointer. So the specialty of this pointer is this pointer points to the same structure employee. See, here I have given as employee star EP, which means what? EP is a pointer which points to the same structure named employee. So if the data member of a structure will point to itself, that type of structures is known as self-referential structures. So this is an example of, simple example of self-referential structure. Now I have drawn a graphical representation of the above self-referential structures. Here this is the first structure, first structure graphical representation. So the first 4 memory locations is reserved for eCode, and the next 5 memory locations reserved for ename, and the next 5 memory locations is reserved for ename, and the next 4 memory locations is reserved for salary. See, and the last data member is EP. EP is a pointer variable which points to the employee. So EP will contain the memory address of the memory location which can store employee type data. So consider if the second if the location 5000, here I have given as 5000 as a last data, that means this is a memory location, this is a pointer, so this will be a memory location, and here it will point to the memory location 5000, and the 5000 is a base address of another structure named employee. So the data member points to the same structure definition employee. Here also from 5000 to 5003 will point to E code, 5004 to 5008 will point to E name, and from 5009 to 5009, 10, 11, 12 will point to salary. So in the last section I have given as for EP I have given as null. That means the memory allocation stops here, which means there is no another data named as there is no another user defined data employee defined in the memory. That is the meaning of null. So in this way we can store any number of user defined data employee in the memory, and each user defined data employee can be linked with the help of the self-referential structure definition. Clear? So hope all of you have understood today's class. So with this class we have completed the theory portion of pointers. From the next class onwards we will be discussing the programs related to pointers. Thank you.